Alright guys, so the mole. Alright, so what is the mole? How is it used in chemistry? What does it have to do with us? Alright, well the mole itself is a value. Alright, we shorten it with MOL there. It is equal to 6.02 times 10 to the 23rd. Alright, it was named in honor of Amadeo Avogadro, so sometimes if you hear us say his name, you should know that that is associated with the mole, right? And what he did is he determined the volume of 1 mole of gas, and he took a couple different gases, and he discovered that by measuring their volume, that no matter what type of gas it was, he came out to this number as being how many molecules or atoms made up that volume of gas. So we're going to take a look at that, and hopefully it'll make more sense as we go. All right. So what is it related to? How big of a number is it? Well, here you go. Here's a few cool facts for you. All right. So if you took that number 6.02 times 10 to the 23rd and you turned it into stars, right? So astronomers estimate that there's 1 mole of stars in the universe. So a whole lot. If you had a whole high school full of textbooks, right, it would cover the whole USA to a depth of 300 kilometers, right? So that's how many, if you had that many moles of textbooks, or if you had a mole of textbooks. If you had a mole of marshmallows, right, it would cover the entire U.S. in a depth of 105,000 kilometers. So that's a lot of marshmallows. 1 mole of moles, right, the little small animal mole, if you place them head to tail, and they're not very big, that would stretch 11 million light years and weigh almost as much as the moon. If you had a mole's worth of pennies, right, and you just stack them on top of each other, they would make 7 stacks that could reach the moon. And then if you had 1 mole of watermelon seeds, it would require a watermelon the size larger than our moon in order to hold all of those watermelon seeds. So it's a really big number, but we're talking about really small things. So it's not as big to us as we would think, but it is a lot of atoms and molecules. Alright, so what it is related to for us, if we look at the periodic table, is it's related to the molar mass. Okay, so the mass in grams of 1 mole of any substance is just what that molar mass is off the periodic table for that element. Alright, so for example here nitrogen, alright, nitrogen's molar mass is 14.007 grams. Well, that's how many grams it takes to make 1 mole of nitrogen. Alright, it's 6.02 times 10 to the 23rd, which is the same number as if I had 1 mole of carbon. But in this case, it only takes 12 grams of carbon to get to that same number of 6.02 times 10 to the 23rd. And that's just because carbon being slightly lighter and all that. Okay, so no matter what, it's just the molar mass off the periodic table. Alright, so here if I'm trying to find a compound, well now if it's a compound, I'm simply going to take the masses of each individual compound and add them together. So here's sodium chloride, right, salt. Well, I take, how many sodium chlorides are there? Well, there's only 1 sodium and there's 1 chlorine, right? So if I need 1 mole of each, well, sodium is 22.9, chlorine is 35.4. So when I add those two together, I end up with 58.3 grams of salt, and that's how many grams I need for 1 mole of salt. Alright, if it's calcium chloride, well, there's only 1 calcium in the equation, or in the formula there, so calcium's mass off the periodic table is 40.08 grams, and chlorine's is 35.4. Right, but there are 2 chlorines in that calcium chloride, so I have to multiply it times 2, so that gives me a total of 70.8. Then when I add those two together, I end up with 110.88, and that's the total molar mass, right, for calcium chloride. So that's how many grams I need in order to reach that 6.02 times 10 to the 23rd moles. All right, so it's pretty straightforward. All you got to do is take the number of each individual element and then multiply that times its mass, and then add it all up. Alright, so here's some examples, right? So we're going to do these. We've got carbon dioxide here. Alright, we've got, this is hydrogen peroxide, right? And then we've got sugar, basically, right? So we're going to take a look at these and see if we can figure out the molar mass, okay? So let me flip over to where I can draw. Alright, so I've already got kind of the first one worked out here, right? So if I look at carbon, right, CO2, alright, well carbon's mass, and I'm just going to write the mass up here above it, right? Carbon's mass is 12. Alright, and there's only one of them. Okay, so I'm just going to put that right there. Alright, oxygen, its mass off the periodic table is 16. And I'm just kind of rounding to make this easier. Alright, so, but there are two of the oxygens, right? So 2 times 16, 32. So when I add those together, okay, I end up with, draw some equal signs here, right? I end up with 44 grams. Okay, so that's my total molar mass there for carbon dioxide. So all I did was take the 12, there's only one 12, there's two 16s, add it all up, I get a total of 44. Alright, so if I'm doing the hydrogen peroxide here, right, well hydrogen's mass is 1, right? But there are 2 hydrogens, so that's 1 times 2, so 2. Now, oxygen's mass is 16, right? So there's 2 oxygens, again, just like before, so that would be 32, right? So now 2 plus 32, that's going to give me a grand total of 34 grams, okay? So that's my molar mass for hydrogen peroxide there, that H2O2. Alright, so now for the big one here, right, sugar. That's C6H12O6. Alright, well carbon's mass is 12, but again, there's 6 of them. Alright, so 6 times 12, that should give me 72. Alright, then I'm going to make my plus sign there. Hydrogen's mass, again, is still just 1, but there's 12 of them, so 1 times 12, 12. Alright, and then oxygen's mass is again 16, but there's 6 of them, so 16 times 6, that's going to give me a total of 96. Well, then when I add those all up, right, that's going to give me a grand total for the molar mass of 180 grams. Okay, so hopefully you see it's pretty straightforward. All you got to do is look at the molar mass for off the periodic table for that element, then look at how many are in the formula, multiply, and then just do that for each one, and then add them all up. Alright, so that's how you find the molar mass, and that's what we're going to be working on when you guys get in class on Friday. Alright, we'll see you guys then.